All right, let's look at another problem here. It says find the area of the region that lies inside the circle, r equals 3 sine theta, and outside the cardioid graph of r equals 1 plus sine theta. So first let's look at what these graph out to be. So open up your graphing device here. Let's go to our polar curves here. Again, make sure you're in polar form. Let's type these two in. So we got 3 sine theta is one graph. And then our other graph here is 1 plus sine theta. And we're going to graph both of these on the same one. I'm going to do this. Let's go on that decimal one, number 4. So if we graph these out, there's our circle, there's our cardioid. And this wants us to find what is the area inside of that circle, but outside of that cardioid. So I think what we're trying to find here, if you look at those two graphs, here's another picture of what this looks like, is inside the circle would be anything in here, and then outside that cardioid means we don't want to be inside that. It looks like the overlapped is what's kind of colored in orange here. So we're trying to find what's that orange area in between them. In order to do that, if you recall how area works here, like if we were just doing the circle, if I wanted to find, say I started right here and I wanted to find what's the area of the circle from this point to this point, I'd have to find those two angles, and it would give me all this area carved out inside of that circle. Or if I did it from 0 to pi over 2, they would give me the area of a semicircle, half the circle. Well, if we're going to find the area between these, what we need to know is what is the area, or what is the angle that gives us that point and that point, because that would carve out this area in between. So we got to find those intersection points. Recall from before, just like when we were in Cartesian, if you want to find those intersection points, set these two functions equal to each other and then solve them out. So we want to solve this out and see what this would give us. In order to solve this, let's get our signs together here. So let's minus sine theta to the other side. And that's subtracting from another like term here. So 3 sine theta minus 1 sine theta is going to be 2 sine theta equal to 1. Let's divide by 2 here. So now we got, where is sine theta equal to a half? If we want to solve that, two ways you could think about it. Where's sine theta going to equal a half on the unit circle? So you could bring up unit circle. We know if we're talking sine here, that's a y value. That's positive. So that's got to be either in quadrant 1 or quadrant 2 here. And then what type of triangle on the unit circle would give us 1/2 as the y value? Well, that would be if we were looking at, I believe here, yeah, that would be if we had a 30-degree angle, I believe, because that would be, the radius is 1 because it's unit circle. That would mean that side's a half, and this side's square root of 3 over 2. So it looks like when the angle's 30 here, and also 30 in that one, which means the two answers here are 30 degrees and 180 minus 30 degrees, or 150. If you convert those into radians by timesing by pi over 180 to both of them, you can get that same thing in radians. This one would be pi over 6. And then 150 over 180 as a fraction would convert to 5 pi over 6. So those would be our two intersection points. That's pi over 6, and this would be at 5 pi over 6. Other way you could also solve that would be with inverse. If you weren't sure from unit circle, you could do inverse sine of 0.5. You get that. This is in radians. My calculator's set in radians, so I'd have to divide that by pi. And And as a fraction, you can see that that's our 1/6, so that's our pi over 6 answer, and then you'd have to find that similar angle in quadrant 2. Okay, so now that you got those intersection points, now we should be able to set up and find this area. So what we want to do, or how do we set up and find just the shaded one? Just like you would area between two curves any other way, you want to take the bigger one minus the smaller one. So what we are going to do here is to find area between two polar curves over the same change in angle from A to B is take your more outside one, which the integral would be A to B of whatever that curve is, minus this one that's kind of in more, not as far out, G, subtract that same integral from A to B over this 1/2 radius squared d theta, and that would give you. If you want to write it as 1, you could, and then like take the common 1/2 outside the integral, and then it would just be the f of theta squared minus the g of theta squared with that one common 1/2 factored out and put outside. Either way is fine. So let's do that same thing here. We want to subtract these. So the one further out you can see is the circle here, that pink or red circle there. So our first integral for our area here, we want to do, let's start with our integral, sorry. We want to do the integral from pi over 6, which we just found was one intersection point, to 5 pi over 6. And that one's going to be 1/2. Our radius here would be our 3 sine theta squared d theta minus, and now our second integral, same thing, from pi over 6 to 5 pi over 6 of 1/2. This time our radius for the cardioid, the inside one here, is 1/2, or 1 plus sine theta. So 1 plus sine theta squared d theta. And if we find this out now, this should give us that area in between. To solve this one, you could again use your calculator to evaluate and see what you get. So let's use our calculator to evaluate this one. So if we want to do integral, so I'm going to do my integral here from pi over 6 to 5 pi over 6. And then we're entering in here. Now we got our that 1/2 in here, so you could do like 0.5 if you want. And then I'm starting a parentheses here because I want that whole function squared. So 3 sine theta. We got to close up that parentheses that they had for the sine theta there. Close up this whole parentheses for my 3 sine, and then square it. And then over here, d theta. So that's going to give me just the one on the left there. If you hit enter, you get this. Let's see if pi is part of this. It doesn't appear that it may be as well. We'll stay with where it's at. Let's do that other one now. So if we do the second one, and I'm going to go up here and copy and paste this. So I don't have to re-enter all of it. I'm just going to change the function in here since we're using same limits. So let's do 1 plus sine theta squared, and I actually do want to make sure this is there's parentheses around here, so I'm going to put a parentheses there, and I should have had shouldn't have erased that other one here, so I'm going to insert a parentheses here. All right, so this should give us our other one. So there's our other value. And now we want to subtract those. So if I'm going to go back up, copy and paste my value from here. This one minus the one we just got. And this should be our final answer. And it looks like our final answer comes out to be 3.4159, and you should notice that is pi. So it looks like the exact answer comes out to be pi. The exact area right here is pi for that one.